3 reminders. Be patient when working with conductive thread. 2, cut your thread away from your fabric. And 3, keep your positive and negative circuits completely away from one another. Today I'm working with a swatch of fabric on which is screen printed the positioning of a coin cell battery holder, a switch, and LEDs. The positive and negative terminals for each of these are indicated on the fabric. Remember that we encourage you, before sewing, to mark where each of your electric components will be placed and how you'll orient the positive and negative sides. Here I have one circuit already sewn, as you can see. It's a simple circuit activated by a button switch, right there. Now, during this demonstration, I'll create a second circuit which will be powered by the same coin cell battery. Sew the positive terminal of your coin cell battery holder. Sew 3 stitches. Once you have 3 stitches securing your positive terminal, then begin making neat running stitches toward the position of your slide switch. So today, as we have in class, we're going to use a slide switch to activate our current. So I'm just endeavoring here to make just some neat running stitches. So there's the first one. And here's another one. I'm going to try to get it about the same size as the first one so I can actually see my work. And we're going to try to get it as neat on the back side as we have on the front side. So, in case we have to rip anything out at any point, we can actually see our work and distinguish one stitch from the other and make the redo process a little easier. Okay, so 3 running stitches up to the position of our slide switch. You may remember that our switches are marked with on and off indicators on the switch itself, but there isn't a positive or a negative terminal, so you can sew down either side. It doesn't matter which side you start with. Just remember that whichever side you choose, you're beginning with your positive circuit. Okay, so we're just going to come up through. Okay, and we're just going to pull that down in there snugly. There we are. Okay, and now we're just going to pick up our work, and we're actually going to cut away from at a 45-degree angle. Cut your thread away from your fabric. And now we'll sew the second side of the switch. We've cut and tied. We're beginning again with sewing the second side of our slide switch. So a goosefoot configuration. The teaching assistants would tell you this is more of a chicken foot than a goosefoot configuration. But I think you get the idea that we just want 3 to 5 distinct stitches Oops, there's a small knot. Okay, let's take a break to get this out. And now we can make neat running stitches toward our first LED. I'm putting our first LED in place. This is a nice pink LED. And of course, if you guess that I'm sewing down the positive side of the light, you're absolutely right, because this is our positive circuit. Okay, so as before, we'll secure it with 3 stitches. Okay, now, do we sew down the second side of our LED? No, we don't. We go to our next light, so let's make a running stitch. And then we'll finish that off with our last LED up here, after which we will tie and cut. We have our 3 LEDs sewn down on their positive sides. Now we're going to tie and cut. So pick up a little bit of the fabric. Great, we're not showing on the front side. Pick up a couple of fibers. We're going to pull through our needle. We have a loop here created by our remaining thread. If you can see the loop, there we are. Put the needle back through your loop, and then guide it down gently. Remember, this gets a little sticky and the thread is easily tangled. So we're going to guide our thread down into a knot that lays flat against our fabric. And now, as you've heard me say 100 times, we're going to cut your tail away from your fabric, and we're going to cut at a 45-degree angle. Now we're not going to use this bottom piece ever to sew on, so we can go ahead and cut over top of it. And remember, we do this, there we are, 45-degree angle, so that we don't have any traces of the conductive thread hanging onto our textile and creating a bypass that will prevent our light from lighting. Okay, we've got positive down. Now let's do the negative side. Now we can sew down the negative terminal of our coin cell battery holder. Okay, our battery holder is now all the way down. I'm just going to make a row of neat running stitches leading up to the first negative terminal, or rather the negative terminal of our first LED. And if you need to check your work on the back, though I'm not looking at every single stitch, don't be afraid to turn it over if you need to every time you make a stitch to see that your thread is not knotting and that it looks the way you want it to on the back side. 3 stitch. Keep moving. We're not going to tie and cut. We're going to keep sewing one LED after another. And to make those 3 stitches, if you want to put 1 stitch in the middle and then 2 on each side, that's all I'm doing. Okay, let's make 1 or 2 running stitches up here to our last LED. Make sure we're not going to tangle. Okay, we've completed the negative side of this circuit. So now all that is left to do is to tie and cut. Okay, let's insert our battery and see if our circuit works. If for some reason the battery fits loosely in the coin cell battery holder, just depress the top a little bit and that will bend the metal enough to hold the battery securely in place. Okay, let's flip our switch and see what we've got. So that now that the switch is flipped, we have a closed circuit. Everything is continuously flowing, and that's indicative of a closed circuit. Over here, being operated on the same coin cell battery, we have an open circuit until we press the button, and aha! Over here now too, with both switches flipped, we have two closed circuits. We let go of the button, it interrupts the current, and we once again have an open circuit. Okay, let me show you how our traces can actually interfere with circuit flow. On the back right now, you can see all of our tails are apart from one another. However, if we had a tail that was actually interfering, the positive interfering with the negative circuits, let's see what that does. We press our button and look what happens. Because the tails are crossing, it creates a bypass and therefore interrupts the flow of the current. Alright, so if you for some reason are not getting your lights to light up, check the back of your work. Make sure that your tails, your traces, are not touching, that positive and negative are completely away from one another. Flip it back over and try again.